Good day, ladies and gentlemen, and today I want to prepare you for our Delta Math second quarter assessment number 2, which can have an incredible impact on your grade for the entire year. It is due Tuesday, December 22nd, and I'm hoping that if you keep up with the checkpoints, every student can get over 100 on the entire project. The important dates you're going to need to know is that 10% of the assignment is due on Friday, December 3rd. That's this Friday. 25% will be due on December 6th. That is Sunday night at 11:59 p.m. I will grade up to 40%, which could earn you up to 160% on a quiz. 40% of the assignment will be due next Thursday the 10th, and it will be a homework out of 40 points. And 55% of the assignment will be due the following Sunday. It will be graded as a quiz as well, and I will grade up to potentially 70 out of 55 points, which can get you 127% actually on 2 quizzes. The following Thursday, you'll have to have 70% done, and that will be a homework out of 70 points. And then that last Sunday before the due date, 85% of the assignment will be expected to be completed. It will count as 3 quiz grades. I will grade up to 100% if you're entirely done, and you'll get 100 at 85 or 118% on 3 quizzes. The entire assignment, 100%, is due on December 22nd and counts as an exam grade. You must have all the supporting work to get the actual grade, and you'll be graded on your completeness, organization, neatness, and any additional questions that you might do. It's important to remember that there is a rubric that goes along with these assignments, and there's a bunch of things that you should be getting more used to. You can check a lot of your questions' answers before you actually input them into Delta to avoid the red X. The red X means you'll have to do questions over again, so you want to try and prevent yourself from getting any wrong. Delta's not wrong. Don't put the same answer in twice. Before you click out of a wrong solution and try your second attempt, read what your misstep was and see if Delta gives you some information on how to improve it. Investigate several model problems. A lot of times there's a model problem almost identical to the one you're doing, and that'll help you to figure out what the steps are that you should be taking. Go back to the model problems often if you find yourself lost within a question. Delta will often give you a clue about what you did wrong, as I mentioned a moment ago, so read what they're suggesting you could improve on before you put in your next selection. Be precise in your answers. Delta often wants a very specific answer, and a lot of times it's going to ask you to either simplify your result, or it's going to ask for something like variable agreement. It's going to want you to use a particular set of letters to use instead of X and Y, and you must use them precisely and accurately, or you will get it wrong, even if your relationship numerically is correct. Delta's not always the most efficient model or way to do a problem. If we do it differently in class, that's usually what I expect you to do. If I see any other methods that seem a little awkward, I may assume that you're doing that through a inappropriate application and getting help from somewhere that you shouldn't. Come for extra help early in the assignment. Don't get behind. Try and work ahead, and if you work ahead, you can have a fantastic grade for the entire year. Make sure that your work is complete. You can earn extra points in that. If I don't see the supporting work, you could lose a lot of credit for that. Make sure it is neat. You can earn extra points there, and if it's too sloppy, you could lose a lot of credit there as well. Same thing with organization. You should be labeling the skills you're doing, and it should be easy for me to follow. And if it is, I'll give you extra credit for that. And if it's not, credit will be taken away. Whatever Delta says you score on the actual percentage complete, please understand that you will either earn or have credit subtracted for each of those 3 areas. In addition to that, you can have extra credit earned for potential extra questions you do within each skill. You can get a half point extra for each question you do, or for 1 question per skill for the 20 skills. So you could earn a maximum of 20 extra questions done, 1 for each skill, times a half point each. That would be an additional 10 points. You could actually earn a maximum of 116% on the assignment. The skills are listed here. There's 20 of them, and each skill counts for 5% of the assignment. So when you finish 2 equations with decimals, you will get 5% of the assignment complete. And it goes for each of the individual skills as you work your way through. A majority of the skills are ones that we've already worked on. So up to skill 14 are skills that you've seen through this year in the previous assignment or assignments prior to that. We only get into the new skills we only begin to investigate the new unit in skills 15 through 20. So there's a lot of rehearsal and review going on in this assignment. Please remember, I am limiting attempts on this particular assignment. It's already been done, so you will not have the opportunity to just select randomly through multiple choice and hope you get it correct. If I see that as I'm grading assessment number 1 for quarter 2, this will negatively affect your grade. Please don't do that. Make sure that you're learning the appropriate process. I know when you're working, Delta shows me everything, so be sure to understand that it gives me all the indications of the effort you're putting in, and effort matters a lot. Make sure you're working often. I shouldn't see that you haven't been in Delta for weeks at a time. That's a big problem. I know if you're using an app, ladies and gentlemen, there's a lot of ways that I can identify the process that you're doing and if it's appropriate or not. Several students had their deltas reset in the beginning of the previous assignment, and that will happen again. Several students that I know are using an app that I wasn't willing to reset the assignment will lose credit on Delta quarter 2 assignment 1 as I begin to grade it. So please make sure you're doing the work on your own. I have a strong idea of who's doing your assignments. Delta gives me a lot of different ways to investigate how your work is being done and who's doing it. That is something I'll be looking at as I grade Delta quarter 2 assessment 1, and you will lose significant credit and or get a 0 if it looks as though somebody else is doing your work. So make sure that you're being honest in the work that you do. Delta shows if you're trying to help yourself. It also often gives me an idea of whether or not you're watching some of the videos that Mr. Korzak provides. Here's a really cool example of how one student was helping himself to complete the skill sets on the previous assignment. you can see that they were watching a video in each of the skills as they worked through it. And in many of those instances, the video was helping them be very successful. You can see in one particular instance, they watched the video twice because they weren't really getting it, and they had to go back and make sure that they truly understood what was going on, and then they were able to get the questions correct. That is a fantastic effort. And even though the student actually didn't get to 100%, I'll take that into consideration when computing their grade. Folks, it is your job to make sure that your work looks unique. I am not a detective. I will not play one in this class. If your work does not look unique or authentic, I will challenge you. And if you're not able to produce the appropriate evidence to suggest that you did your own work, you will get a grade that represents that. In most instances, a 0. The burden of proof is on you. You have to show that you're learning. That's what this course and this class is all about. Stay positive, stay organized, give a good effort. I believe great things are going to happen. Tips to success? Make sure you hit the checkpoints. Try not to fall behind. It will positively affect your grade, especially if you work ahead a little bit. You'll be earning extra credit throughout the entire assignment for your entire course grade. Have a plan. Failing to plan is planning to fail. Have a backup plan. Have a backup plan. Where are you going to do your work? When are you going to do your work? Do you have a second? Do you have a third plan? You should. Otherwise, it's going to be really hard to be successful. Get help early in the assignment. Come to the virtual extra help sessions. They happen at Tuesday from 3 to 3:45 and on Thursday evenings from 7:15 to 8 o'clock. Students who've come to them have dramatically increased their grade. Certain students have gone from as low as a 14 up to a 90% in our class. That's absolutely amazing. Reach out to classmates that might need help if you're a strong student, and stay in touch with classmates that you can help and stay on top of their work. So give them encouragement and help them to do the best they can. It will help us all get a lot further. As you look into the class stream, what you'll notice about this week is that you have 10% of the new Delta assignment due on Thursday night, and you should get working on that as soon as possible and try and get beyond that. And then Friday through the weekend, you'll have 25% due by Sunday. So I recommend you get that done as soon as possible. If you're able to do it all on Thursday, you'll have nothing to do throughout the entire weekend, or you can continue to work ahead. The skills look like this. The very first skill is going to ask you to solve linear equations with decimals. We know they're linear because it's x to the first power. And typically we're going to begin solving linear equations by distributing. So we're going to have to share multiplication into a grouped quantity. Mr. Korzek shows that really well in his examples. So we have to distribute in the expression on the right, -9/10. We also have to distribute a -1 in the expression on the left. I would have taken care of that right away. Mr. Korzek waits to the third step to do that. Once distribution has happened appropriately, you're then going to collect like terms. The expression on the right allows you to collect 9x's and 10x's to put them together for 19, as well as collecting your numerical values of -4 and 8/10 and -4 and 5/10 for a total of -9 and 3/10. I would do this differently at this point. If it were up to me, I would choose to transfer a variable. It's not my favorite method that Mr. Korzek chooses to transfer the numerical quantity. It's not incorrect. You can add whatever you want to an equation as long as you do it equally to both sides. But my preference would be to add +1x. I like to move or remove the lesser of the two variable values from both expressions. That allows us to work with less negative signs as we continue to solve through the relationship. And mine would look a little bit different than his, and I would continue to get the same answer. The answer, by the way, is a non-integer. Integers are the whole numbers and their opposites. Whole numbers don't have any partial values because they're whole numbers. So it is a non-integer rational quantity. Rational means fractional, and 3600ths could be written as 36/100 and simplified on your calculator if you needed to. For the next skill, solving equations with fractions in it, Mr. Korzek does it entirely different to me, and I actually don't prefer his technique. Mr. Korzek begins with distribution, which is a step that I like, and that can be done on your calculator. If you're not sure how to do 10 times 6/5, just type it in, you'll find that that's equal to 12. And he then goes ahead and continues to solve by collecting like terms, working with the fraction throughout the entire relationship. My preference would be to clear the fraction right away, to move or remove it with an appropriate algebraic step. I know that fractions have denominators, and denominators mean divide. The opposite of division is multiplication. So I choose to multiply the entire expression by the least common multiple of any and all denominators. There's only one here, and 2 is divisible by itself, so I choose to double both expressions. Multiply both expressions by 2. When I do that, 1/2 x times 2, or if I double 1/2 x, I get 1x. And as I double the rest of the relationship, I'm able to remove the fraction. Then I can simply collect like terms, transfer a variable, and solve appropriately. Be careful. In certain instances, when you transfer a variable, you will have the opportunity, or it will be the case that you'll actually be making the equation equal to 0, which is fine. We're going to intentionally make most equations equal to 0 throughout the rest of the year. So don't be freaked out when your linear relationship is equal to 0. Just continue to solve appropriately. And you'll notice that I get the same answer as Mr. Korzek. He got 8/9, and I got 8/9 as well. I did have to simplify 24/4 on my calculator, and I just used my fraction key to do that. In order to check my work to make sure that it was correct, I substituted 8/9 into both of the expressions and evaluated them. The opposite of 8/9 is -8/9, and in the expression on the right, when I typed that into my calculator using my fraction key and or putting fractions in as grouped quantities, I got -8/9 as well, so I knew my work was correct. For the next skill, number 3, we're asked to write the equation of a line based on its graphical presentation. So to write the equation of a line based on its graphical presentation, the trickiest part about this is that Delta's going to want you to actually show the rise over the run as you're identifying the slope or the rate of change within the line. And it wants you to do the rise first. So it wants you to begin by clicking, identifying 2 points in the pattern. And once you've identified 2 points in the pattern, it would like you to begin by determining how much higher one is than the other. So you actually have to go to the higher of the 2 points, and you have to click to start that vertical segment. Then you have to drag down and click again to end it. And you're showing that in this case, it's 1 unit high. As it travels, you would then click to begin the run piece, and you would click to end it at the end of that segment or that investigated space. And you notice that it runs 4. So by doing the rise first, you're showing that it's going up 1, and then doing the 4, you're showing it's going over 4. So this rate of change is 1/4. Once you found the rate of change, Delta expects you to identify the beginning amount, the value at time 0, which in this case is -1. So the beginning amount is at time 0, it measures -1, and the rise over the run is 1/4. You're then supposed to substitute into y equals mx plus b for m, the rate of change, and b, the beginning amount. If you don't do the graphical piece correctly, you will get this entire section wrong. So you have to make sure that you're clicking the rise and the run appropriately. You could have done this through 2 points, even if you were, once you click the rise and the run, if you weren't able to investigate it or visually see it, you could have identified the 2 points as 8 units of time ago, measuring -3, and 4 units of time ago, measuring -2. You could have then labeled the points x1, y1, and x2, y2, and use the slope formula, substituting using parentheses, along with your calculator for the computations, to determine that the rate of change was 1/4. You then could have substituted that information into y equals mx plus b, along with a value for x and y from one of the 2 points. If you substitute in for y, m, and x, you can solve for b, and you'll notice that you get the same exact amount. The beginning amount algebraically comes out to -1, which is exactly what it was graphically. You would then substitute m and b into the slope-intercept formula y equals mx plus b appropriately and get the appropriate answer. For the next skill, ladies and gentlemen, skill 4, you're asked to do exactly what I just showed you in the previous example. You're asked to determine the equation of the line passing through 2 points. So you're not given the graph to work with, and you have to strictly work with the numerical quantities. That's going to require you to label the points x1, y1, and x2, y2. So right now at time 0, x1, y1, the relationship is measuring 8. And our second observed times, x sub 2, y sub 2, happened 8 units of time ago when it measured -4. If you label them appropriately and substitute that information into your slope formula, I wish Mr. Korzak would use parentheses here. That makes me a little bit crazy, because it's easy to make mistakes when you're not using parentheses in your substitution. You'll find that the rate of change is 3/2. It's increasing 3 measured amounts every 2 units of time. Once you know m, you have to solve for b. Now this particular question is kind of strange because they actually gave you b. They told you that at time 0 it's going to measure 8. But if you didn't know that, you could have substituted into y equals mx plus b to determine what 8 was equivalent to. You could have used either of the 2 points. Mr. Korzak uses 0, 8, and he says that the relationship is going to measure 8, substituting in for y, as a result of going up 3/2 0 times. Well, if it didn't go up 3/2 at all, then it must have begun measuring 8, exactly what we see in that particular situation. Once you know m and b, substitute appropriately into your slope-intercept form, and that skill would be completed. For number 5, you're asked to solve a system of equations graphically, and system means more than one. So to solve a system of linear equations graphically, by the way, we know they're linear because both of the x values in the relationship are being raised to the first power, you're going to have to identify the slope and y-intercept, m and b. In the first relationship, when you do that, you're able to see that the slope is -2/1, and the relationship starts at a measured amount of -6. So you're going to begin your graphing at 0, -6. You're going to hit, click your mouse, right-click your mouse to start that graph, and you're going to go down to and over 1, and a line's going to appear, and you'll have that relationship graphed appropriately. For the second equation, it's a little bit trickier because it's not in slope-intercept form. It's not solved for y. It doesn't say y equals mx plus b. So you're going to have to use appropriate steps to move or remove the x value, subtract 1x from both expressions, divide by -2, and then you'll be able to identify m and b appropriately. To graph that relationship, you'll start at 0, -1, and you'll go up 1 and over 2, clicking your mouse appropriately to make the line. Once you've done that, you should notice that the solution to a system is when the relationships measure the same amount. And in this particular instance, 2 units of time ago, both relationships measured -2. I had to go back 2 and down 2 to determine that 2 units of time ago, they both measured -2. And you would submit your answer. For skill number 6, ladies and gentlemen, it gets a little more complex because you're dealing with a context question, so it's a word problem, and you're going to have to decode appropriately. It's a little tricky to decode on your computer, but I wouldn't stress that. You'll figure it out. And you can take some notes as you work. I noticed that this particular question was talking about a person working 2 jobs where they were making $18 per hour for one and $9 for the other. The tricky part for this is that the second equation is a relationship. It says that they worked 4 times as many hours tutoring as they did clearing tables. So once they tell us that tutoring is the x variable, I know that x is going to have to be equal to 4 times the value of y, because he worked 4 times longer. That's tricky because it's not equal to a total, it's equal to some sort of specific relationship between the 2 variables. As I created a let statement by reading the question, I knew that I was supposed to let x equal the number of hours tutored and y equal the number of hours clearing tables. There was a total here, it was the amount of money they earned, so I made $162 equal to the amount of money they earned for tutoring, $18 per hour, as well as, or increased by the amount they earned clearing tables, $9 per hour. So I had one question set equal to a total and another that was a relationship. So I had 2 equations where one was equal to a total, those are often my favorite, and the other relationship, a little bit tricky, was where the 2 relationships were related to one another. If I was to solve those each to put them in slope-intercept form, it would require me for the money equation to subtract 18x's from both expressions and to divide by 9. I could then identify M and B and graph appropriately. I'm starting at 18 possible hours, clearing tables, and I'm decreasing 2 hours for every hour that I tutor. Or that's what I would need to do to replace the amount of money that I lost. So for every 2 hours that I clear tables at a rate of $9 a piece, I'm losing $18, and I would have to tutor for 1 hour to make that up. For the second relationship, where the amount of hours tutored was 4 times the amount of waiting tables, when I solve for y, I simply have to divide both expressions by 4, and I find out that you would have to work change in y over change in x, 1 hour for every 4 hours according to this relationship, and the amount of times he spent doing each. It starts at 0, so I start at 0, 0, and I increase 1 hour for every 4 in terms of how he was hoping to plan his time out. I find out that the solution to the system and what he actually worked was 8, 2. 8, 2, meaning he tutored for 8 hours, that's the x variable, and cleared tables for only 2. And that sounds kind of smart because he was making more money tutoring anyway. And that's the result, or that's why he was able to earn $162. You could check your work, you could substitute in, is it true that $18 per hour times 8 hours increased by $9 per hour for 2 hours does in fact equal 162. And when you put that into your calculator, you'll find out that that is how he earned his money. And you can move on to the next question. For the next question, ladies and gentlemen, you're determining if a pair of a set of points is a function. And what you need to remember about a function is that a function is a useful equation that makes predictions one at a time. 90% of the time, the x-axis is time. Therefore, the x values or variables must be unique. They may not repeat. So all you simply have to do is investigate each set of points and make sure that the x values are unique. They want to know which one is not a function. So I'm looking to see for the set of data points where there is a repeat in the x variable. And I find it in the second set. There's 2 predictions at time 9, and therefore that is not a function. Similarly, in the next skill, you're doing that graphically. And on a graph, a relationship will be a function if it passes the vertical line test. If you're able to slice it with a vertical line, and at any point in time, it does not have more than 2 intersections with your vertical line. What that actually means is that there's only 1 prediction at that time. So if you look at the first graph, 1 unit of time from now, it intersects a vertical line with a measured amount of 5. So it's 1, 5. 1 unit of time from now, the relationship will measure 5. The same thing happens 3 units of time from now when it measures 6. 3, 6. 3 units of time from now, the relationship measures 6. And again, you can see it's 6 units of time from now when the relationship measures 3. There can be many times when the relationships measure the same amount. There just can't be more than 1 prediction at a time. When you look at the second graph, we run into some problems. And we run into some problems because there's many instances where at the same point in time, there's more than 1 prediction. So if you look back 8 units of time ago, you'll notice that 8 units of time ago, this relationship measured -3, and it also measured -4. That's 2 predictions at the same time. That is not a function. And the same thing happens throughout the relationship at many different times. If I were to go 6 units of time from now, I would notice that a vertical line drawn on this graph would show that it measures -2, and it also measures -4. So 6 units of time from now, it could possibly be -2, and it could possibly be -4. That won't be useful when we start to translate this information in context and think about medicine and engineering and finance. We don't want to have somebody take a medication and say, well, maybe you'll live tomorrow or maybe you'll die. Nor do we want to make an investment and say, hey, maybe we can make you some money or maybe we'll lose all your money. So in order for a relationship to be a function graphically, it must pass the vertical line test. You should be able to draw a line, straight line up and down at every single place in the graph, anywhere you want, and you should never have more than 1 point of intersection. For the next skill, we're solving a system of equations and determining if there are 1, none, or an infinite number of solutions. And this is something that you guys struggle with, so let's see if we can get a little better handle on this. When you solve a system of equations in standard form where x and y variables are in the same expression, we usually solve that through cancellation, which I'll show you in just a minute. But it is possible to have taken both of these relationships and to have chosen to put them in slope-intercept form, solve for y. If you did that for this first set, what you would see is that the 2 relationships have different slopes. One is going up really fast, 3 times the value of the x, and the other one's going up a little slower, 3/2 the value of x. But because they have different rates of change, they will intersect at some point in time if you graph them, and the intersection is the solution. This particular graph intersects 1 unit of time from now when both relationships measure 4. That's the solution to the system. It happens because they have different rates of change. If you were to solve it through cancellation, you'd have to get inverse variable amounts. I chose to get my y's to be opposite amounts. I knew the opposite of positive 2y was negative 2y, so I multiplied the whole first relationship by -2. You can multiply an equation by whatever you want, as long as you do it equally on both sides. What I found out is that when I solved for x, it was true that in 1 unit of time from now, both relationships were going to be equal. I could continue to solve for y and figure out that they're going to measure 4 at that moment in time, but all I needed to do is to determine if there was a solution, and there was. 1 unit of time from now, there'll be a solution, and therefore there is one solution. It is possible, however, that there could be no solution. So if you look at the second example that I'm giving you, I was able to take these 2 equations and put them in slope-intercept form with correct algebraic steps, and I noticed that the 2 relationships had the same exact slope. Because they have the same exact slope, they're going to be parallel. In addition to that, they had different y-intercepts. They were crossing the y-axis or starting at different amounts. This was really tough to see. I actually had to zoom into my graph really close because it almost looked like they were on top of each other, but they weren't because they don't have the same y-intercept. When I graphed them, because they were parallel, they would never intersect, and that means there will never be a solution. If you were to solve it through cancellation, it doesn't matter which variable you cancel, x or y. In this particular instance, I chose to cancel the x because I knew that the opposite of negative 4x's was positive 4x's, so I multiplied the whole first equation by 2. I doubled it. I got an equivalent equation that just looked different, and when I added it to the first, in a method of cancellation, treating it as one giant equation, taking the equivalent algebraic expressions on the left, or the sum of the equivalent algebraic expressions on the left, and making them equal to the sum of the numerical quantities on the right, I got an untrue mathematical statement. The entire algebraic expressions canceled out, leaving me with 0, and the numerical expressions equal -1. And 0 never equals -1. And the reason that happens is because in this system, there's no solution. The lines never intersect, therefore there is no solution. In the last instance, ladies and gentlemen, it is possible that when you're looking for the number of solutions to a system, the lines can intersect one another and have one solution, be parallel and never intersect one another, or you could actually get a copy of the same line graphed on top of itself. That happens in a lot of instances in the real world, where there's an infinite number of ways to solve a problem. So what we notice is, if I were to take the two relationships and put them in slope-intercept form, I was able to determine that they're exactly the same. The first relationship was the same as the second. When I put that in my calculator and I graphed it, it was really weird because I only saw one line. The reason I only saw one line in my graph is because the same line was graphed on top of each other and it covered up the one underneath it. When I looked at my table of values, I noticed that at every unit of time, 1 unit at time 0, 1 unit of time from now, 2 units of time from now, 3 and 4, and forever throughout my table, the relationships measured the same amount at every point in time. That indicates there's an infinite number of solutions. If I were to solve this algebraically through cancellation, because the original equations were in standard form, and that's usually what we would do, we'd treat it as one giant equation. If we had inverse variable amounts, we could add the sum of the algebraic quantities and make them equal to the sum of the numerical quantities. In order to do that, I chose to recognize that the opposite of positive 8x's was negative 8x's, so I multiplied the entire first equation by -2. Some people like to do that by putting the entire equation in parentheses and putting the constant that they're going to multiply by outside of the entire relationship, distributing to the expression on the left as well as the expression on the right. When I did that, I found out that by adding my expressions on the left together, the algebraic quantities, they canceled completely, and I was left with 0. When I added my numerical quantities, they canceled as well, and I was left with 0. The reason is that technically I'm subtracting the same line from itself, and anything minus itself is going to equal 0. 0 will always equal 0 if that is the result of your system solution. And what that means is there will be an infinite number of solutions. It doesn't matter when you choose or how you choose to solve this relationship, it's going to have an infinite number of possibilities. In the next skill, I was doing substitution to solve a system of equations. The trick to solving a system is you must use the equations together. You can either graph them and see where they intersect. You can either have both, or you can have both relationships in standard form. That means x and y on the same side, and you can use cancellation. But if you run into a situation where one variable is already solved algebraically, such as this skill, where y equals 3 times x plus 2, you can just substitute that in place of y in the other relationship. And what you get is a single variable equation with just x's in it. A single variable equation with just x's can be solved numerically. You should solve for x appropriately, and after you get x, you should go back and solve for y. These relationships are going to be equal 10 units of time from now. Now the question is, what will they equal? So we substitute 10 in place of x in either of the two original equations, and we determine that they will both equal 32. 10 units of time from now, both relationships equal 32, and that's the solution to the system. For the next skill, we're solving a system once again through elimination, and we're using a level 3 skill set. That usually means that we're going to have to think a little bit harder. So we've got two equations that indicates that it's a system, and we want to solve through elimination or cancellation, and that can only happen if we get inverse x or y variables. In Mr. Korzyk's example, he chose to get the opposite of positive 5x's, negative 5x's, by multiplying the entire first equation by -5. Once he did that, he was able to add the equations together, taking the sum of the algebraic quantities and making them equal to the sum of the numerical quantities, getting his x's to cancel, and solving for y. He found out that these two relationships are both going to measure -7 at some point in time. The question was, when does that happen after that? So he chose one of the original equations to substitute -7 in place of y and determined that it must be 6. 6 units of time from now, both relationships are going to measure -7. You can check your work at this point by substituting into the other equation, whichever one you did not use to solve for y, 5x less 7y equals 79. And you can see if you got it right by seeing if it's true that 5 times 6 less 7 times 7, substitute in for x and y appropriately, does in fact equal 79. And if you to evaluate that, you would find out that it does. 79 equals 79, and therefore we got it correct. In skill number 12, you're solving a system of linear equations graphically, linear inequalities, graphically. And to solve a system of linear inequalities graphically, you have to answer 4 questions about each of the inequalities. 2 questions about the linear portion, what are m and b, and 2 questions about the inequality. If you're graphing an inequality and you have an inequality symbol without an equal sign underneath it, your boundary line should be dashed. In this instance, where it says y is less than, all our measured amounts are lower than the boundary, so we should be shading below. The same happens to be true for the second relationship. When we graph it, for the first relationship, we're going to start at 0, 3, and we're going to go down 1 and over 6. clicking our mouse to begin the line once and clicking it a second time. Delta is going to ask you if you want your line dash or solid. Make sure you choose dash, and it's going to ask you if you want to shade above or below. And the shade's going to jump back and forth as you click that hyper box. Make sure that your shade is below. Do the same thing for the second relationship, and know that the solution to the system is in the intersecting shaded regions. Any point within that intersecting region, any appropriate x and y value, would be a solution to the system. So Mr. Korzak chose one moment of time ago when they both measure 7, but you could have chosen whatever you wanted. You could have said, Tooch, I wanted to pick 6 units of time from now when they both measure -6. That would be an appropriate solution. Or you could have chosen 10 units of time from now when they both measure -4. That would be an appropriate solution. And any point in the intersecting region. Be sure not to pick a point on a dashed line ever, even if that's where the two boundary lines meet. It will not be a solution to the system. It will make an inappropriate relationship, such as 6 is less than 6, which is never true. For the next skill, you're asked to do a system of inequalities in context, which means you're going to have to read the question and determine relationships on your own independently. And we have another job question here. Julian worked 2 summer jobs. He made $8 an hour washing cars and $13 an hour tutoring. He can work a maximum of 13 hours, no more. There's one total. And he must earn no less than 130, which means he wants to earn equal to or greater than that. They tell you that X is the number of hours washing cars and Y is the number of hours tutoring. So you should have a let statement to organize your thoughts to make sure that you have that appropriately selected. Your first relationship is going to have something to do with a total of 13 hours. And that's going to be what happens when you add the hours he worked, X and Y, together. He can work no more than 13 hours, so he can work equal to it, or his expression could be possibly less than. It's important that you get the inequality symbol in the correct order. Once you've done that, you should solve for Y by subtracting X from both relationships, identify M, B, whether or not your line is dashed or solid. In this case, it's solid because we were able to include an equal sign because he was allowed to work 13 hours, and our shade is below because he wants to work no more than that. The second relationship has to do with him earning greater than $130. That's going to happen because he's going to make $8 per hour washing cars and $13 per hour tutoring. And if we add up those amounts together, he wants to make at least 130 or more than, greater than, or equal to, so he could be equal to 130 or possibly greater than. Once you put this in slope-intercept form and substitute that into the hypertext boxes, Delta will plot it for you. You're just going to have to pick your shade. Make sure that when you talk about the total number of hours he can work, which could be all 13 hours tutoring or all 13 hours washing cars, that you shade below because he doesn't want to work more than that. Make sure that when you're talking about the amount of money he wants to earn, which starts with he could simply work 10 hours of tutoring, 10 hours of tutoring at $13 per hour would earn him 130, and 0 hours washing cars, that as you work on that relationship down to the possibility of simply working 16 hours of washing cars and 0 hours tutoring, that you shade above it because he wants to earn more than that. And once again, our solutions to a system of inequality are in the intersecting region. Pick any combination of hours of tutoring and washing cars, make sure it's in the correct order, and substitute in. Mr. Korzak chose 4 hours of washing cars and 8 hours of tutoring, and he could have checked his work. He could have said, is it true that $8 per hour times 4 hours of washing cars and $13 per hour times 8 hours of tutoring will in fact be greater than or equal to 130? And when you substitute that into your calculator to evaluate, it is in fact greater than or equal to 130. In the next skill, this is one we're going to learn as we start the new unit. It's function notation of a linear equation. So function notation is a special way to present relationships as useful equations that makes predictions in the future that allows us to evaluate them without having to use a lot of words to describe it. So we, instead of saying y, we use f of x or g of x. And f of x or g of x simply means a function of x, or as a result of time, or as a result of repeated additions. So we're saying that our y's, or g of x, are a result of starting at -2 and subtracting 1 over and over again. All we really want you to understand is that when we say find g of 1, we want you to substitute 1 in place of x, and you should substitute using parentheses. So that would require you to put 1 in place of x in that original relationship and evaluate. You can do that on your calculator once you get it on your paper substituted appropriately. So I typed the negative of 1, because I was supposed to do the negative of x. So the opposite of 1, less 2, and it came out to be -3. And I would hit enter on my calculator, and it would evaluate appropriately. We're then going to talk about features of a parabola, because we're now into second-degree polynomials, x squares. And second-degree polynomials are always going to make this shape, this curved behavior that's either going down, decreasing throughout time, or increasing throughout time. And it's really kind of fascinating because this is how all behaviors happen for anything that flies across our planet. Anything that is hit or jumps or launches, because we live on a curved planet, is going to happen in a parabolic behavior. So parabolas are going to be really interesting investigations to make. And we're going to talk about the different features of that, and in some instances you'll be asked to identify the roots. The roots of a tree are where it digs into the ground. The roots of a parabola are where it digs into the x-axis. They're technically called the zeros because it's the time they measure zeros, or the x-intercepts. And when you're trying to find the zeros or the x-intercepts, there's 2 ways to identify your solutions. One is to say that 3 units of time ago the relationship measured 0, that's that one. And the other root is 1 unit of time from now when it measures 0. And sometimes we'll just say that our x values happened 3 units of time ago and 1 unit of time from now in what we call set notation. So the two presentations are to write out the coordinate values and show when they equaled 0, and the other presentation is to just say when it happened. Because if we're asked to find the zeros or the roots, we know that it's going to measure 0, so we don't necessarily have to say it. Folks, I think that's plenty to get you started. I hope that you're able to use that information and get a really good jump on this assignment. If you do well on this assignment, I promise you it will make a huge difference in your grade for the entire year. So I'm hoping that every student has a chance to earn a grade over 100. Even still, even if your grade in the first quarter was a 4 and your grade right now is an 8, you still have a chance to earn 100 for the year if you get on board with this assignment now. I apologize for the length. I hope that it makes a difference in your overall ability and grade throughout the class, and I'll see you soon. Take care.